Hey everyone, my name is Eric Jones, better known as a turf teacher. Welcome to the course entitled Architect and Engineer Scales. Now, what you're going to do is you're going to look at a PowerPoint presentation first, and then you're going to look at a video of me using the architect and the engineer scales. So that'll follow this short video on how to basically use them, and then you'll see me actually using them. So let's go ahead and get started. All right, so how to use an architect scale. We're going to do the introduction to scale rulers, and then we're going to look at why architects and designers use them. And basically, I tell my students at the college, think of a car model or any type of airplane model, that we built when we were kids. We're scaling them down. Well, we take that full car or that airplane model that we're building, and we're scaling it down, usually sometimes to 20 scale, right? Well, guess what? Landscape architects, landscape designers, irrigation contractors, we do the same thing. We're scaling that landscape down to where it will fit a piece of paper, usually a 24 by 36 or an 18 by 24, whichever size we are using when it comes to our plans. Now, we also use CAD. We also use hand drawings. We do all of that stuff. So it just depends on if we're doing it by hand or not. And so what is an architect scale? It is a specialized ruler for drafting and measuring scaled drawings. Contains multiple scales, commonly 3 to 12 per ruler. It is different from an engineer scale. I think the architect scale is a little bit harder to use because on the engineer scale, we could actually count each and every tick to represent a foot. With the architect scale, you're actually saying like, hey, 1/4 inch equals a foot, 1/2 inch equals a foot, 1/8 of an inch equals a foot, 3/32 of an inch equals a foot. So basically, if you were to use your good old tape measure, and I have a little red one right here, a little Milwaukee that actually you need to keep in your design toolbox or your pencil pouch, whatever it is that you carry around your drafting tools. And so literally with the architect scale, if you've got 1/4 inch equals a foot, and we have a 1 inch, technically we have 4 feet per inch. Now, I remember one time coming home from college and met my dad on a job site at on a Friday night late. So I had to come home every weekend and work in the landscape business. But I met him on a job site, and Dad had a set of blueprints laid on the back of his tailgate. And I was like, whoa, this is super cool. Dad, what is this? And he's like, this is the landscape drawing. We're actually building this landscape on the paper out in this customer's yard. And I was like, this is really, really cool. And it was Neil Aronson, landscape architect, that drew the plans. And that's what made me change my major from applied mathematics to landscape architecture. And so fell in love with it just on that job site. And as I progressed through my college career, I would come home, help Dad out. And of course, he'd have blueprints out, and he'd be taking one of these, a little tape measure, and he'd be scaling the drawing. I'm like, Dad, you want me to get my scales out of my bag? He's like, no, son, I don't need a set of scales. And I'm like, what do you mean? He said, it's 1/8 of an inch equals a foot. So for every inch on this tape measure is 8 foot. And he was scaling that landscape based off that. Actually, he was estimating a job when that happened. So if you're good with this, you can be good with the scales. So purpose of scales, to represent large structures on a paper in a manageable size. Again, we're taking that huge landscape and we're shrinking it down to a piece of paper that we can take to the field and actually build the landscape. It maintains accurate proportions and is commonly used in architecture, landscaping, construction, interior design, machining. They use a little difference. They may be using a metric scale, but everybody is using it. We need to know the size of things. We need to know how to build it and what size it is. And so when we're looking at that piece of paper and we're reading the scale, we can take our scales, measure it, figure out how much mulch to use, how far the trees are separate, how wide's the sidewalk, the whole 9 yards. It helps us build the landscape. It helps us lay the pipe for irrigation. We can calculate how many feet of pipe based on reading that irrigation plan. With some common architect scales, 1/16 of an inch equals a foot, very small scale. Overall building footprint, that's going to be a lot more in architecture. 1/8 inch equals a foot. Floor plans, 1/4 inch equals a foot. Construction details, 1/2 inch equals a foot. Millwork. In landscaping, in irrigation, there are 4 scales that we're going to see mainly. 2 come from the architect scale. It's going to be 1/8 of an inch equals a foot and 1/4 inch equals a foot. When we look at engineer scales, it's going to be 1 inch equals 10 feet or 1 inch equals 20 feet. And we'll talk a little bit more about that when we jump over to the engineer scale. Now, I have seen plans 1 inch equals 30 and 1 inch equals 50. And I have seen some larger blueprints, or if they're doing more of a overall site plan inventory and analysis where they're using, ArcGIS and all that. I have seen prints larger than that or scales smaller than that where it shrunk it down, but it's a huge, huge acreage property. But the 4 main in irrigation and landscape architect is 1/4 inch equals a foot, 1/8 inch equals a foot. On the engineer side, we have 1 inch equals 10 feet and 1 inch equals 10 and 20. Got it mixed up there, but it's 1 inch equals 10 and 1 inch equals 20 for engineer. So anatomy of the scale ruler, triangular or flat with multiple edges. We'll see a good picture of that here in just a second. Each edge marked with a different scale ratio, and numbered tick marks represent feet and inches in the reduced size. Now, as you can see here, this is the half scale, there's the 1/4 scale. And so with the architect scale, especially this one down here, 1/4 and 1/8 scale is going to be on the same side of the triangle. And so with the 1/8 scale is usually going to be on your left-hand side, so you're going to read left to right. 1/4 scale is going to be on the right side, so you're going to read right to left. So that can get a little confusing. You don't have to worry about that on most engineer scales. But you're going to align the 0, not this information to the left or to the right here. You're going to put it at the 0. That's the correct scale to the start point. Count the tick marks to measure the difference. An example, 1/4 inch equals a foot, 1 inch equals 4 feet. Step-by-step examples. Drawing using 1/4 inch equals a foot. You measure 3 feet on the drawing. The real length, 3 feet times 4. We have a 12-foot real life size landscape. Again, 1/4 inch equals a foot. You measure 3 inches. The 3 inches, we know that 4 inches is in a foot, so we have 12 feet in real size property. Using the opposite end fractions. Fractional divisions allow partial foot measurements. Example, 0 to 12 subdivided into inches. Helps with precise detail like cabinetry or window sizing, and even sidewalks, even shrub beds, stuff like that. So it's those little tick marks that are before the 0. So they're actually taking, if it's an 1/8 inch, they're breaking it down. If it's a 1/4 inch, they're breaking it down. So it's literally that 1/4 inch broken down into even smaller subsets, so that you could say like 8 feet, 3 inches, 8 feet, 6 inches, which would be half of it. So comparing scales, 1/8 inch scale is 1 inch equals feet. 1/4 scale, 1 inch equals 4. Half scale, 1 inch equals 2 feet. Smaller denominator is a larger detail. So the smaller the denominator, the larger the detail. It's going to be bigger. So what do we do when choosing the correct scale? Consider the size of the paper versus the size of the structure. What size paper are you working for? Again, usually irrigation, landscape designs, we're going to be at 24 by 36 sheets of paper, sometimes smaller, 18 by 24, and I have seen 24 by 36. Just depends. 24 by 36 is going to pretty much work for any landscape design. It's your typical blueprint size. If I can shrink it down and get it on, the 18 by 24, especially, for my build prints, where I can take to the field with me, it's a lot easier to work with, but I don't want to reduce the size to fit that piece of paper if I'm going to lose details. Choose the smallest scale that keeps the drawing legible and doesn't lose the details, and always check the title block for the specified scale. Mistakes to avoid: using the wrong scale edge, forgetting to check the drawing's stated scale, and mixing architects and engineer scale. When you see them side by side, there's no way that you're going to miss it. Like, you're going to know that this is an architect and you're going to know that this is an engineer. So the only time you're probably going to be worried about the wrong scale edge is if two of your scales is on the same side of the triangle, like the 1/4 inch on the right side and you have 1/8 inch on your left side. 1/8 inch you're reading left to right. Architect, you're reading right to left, and you're like, whoa, you get somewhere in the middle and you're like, okay, which one is which? So you just got to pay close attention to that. The more you use it, the more you're going to understand that and make it happen. Really forgetting to check the drawing stated scale. Yes, always look at it. Sometimes it may be a graphical scale. Sometimes it may say scale equals 1/8 of an inch equals 1 foot, or they may draw it graphically. Graphically, you can kind of trace over it if you're in the field and actually use it to help you measure in the field if you didn't have a scale or tape measure. Real life application, you can use it for floor plans, elevations, irrigation design, landscape design, pretty much anything you want to draw. You can scale it down and put on paper. A lot of times people use graph paper. You may not necessarily have to use a scale if you're using like one of the blocks in the graph paper that represents like 1 foot or 1 square foot. With pro tips, use a sharp pencil for clarity. Use a mechanical pencil or a Pentel sign pen or a V7 pen. You want to keep it. Use a mechanical pencil that rotates so it keeps that sharp point. Label the scale used on every drawing and double check math with calculator when in doubt. But keep those pencils sharp if you're using some of your sketching pencils, but those are, again, they're used to sketch. They're not used to draw precise drawings. You do this over and over again, and I love the fact that in our industry, a lot of landscape architects and designers are going back to hand drawing plans just for the artistic side of it, and I absolutely love it. Yes, we need CAD, we need LandCAD, we need Pro Landscape, we need all of those digital drawing formats. But for an individual, a designer, to come back and lay down a hand-drawn plan that is colored with magic markers, absolutely love it. This is one of the reasons I got into it, because I love to draw. And I'm like, holy cow, you can actually build people's landscapes and irrigation systems by putting it on paper. So now let's look at how to use an engineer scale. We're going to do the introduction to the engineer scale rulers, why engineers, surveys, and designers use them. So what is the engineered scale? It is a specialized ruler for technical drawings and maps. So yes, when you hear engineer, you're thinking engineer, right? When you hear architects, you're thinking, when you hear architect scale, you're thinking, okay, so this guy or gal is a landscape architect or a building architect. Yes and no. They're just tools that all professions use. It's just based on size. Now, as a designer, as irrigation landscape designer, we're going to use that architect scale for our construction details, more than likely. We're going to use the engineer scale to do the site plan and the total irrigation plan, something that's bigger. If we're using architect scale, our drawings are going to be a little bit bigger. So that's why we use them for details and stuff. If we're trying to shrink that property down and fit it on the paper, that's why we're using these engineer scales. divided into decimal units of feet, not inches, and it's different from the architect scale. And so the purpose of this engineer scale is to represent large projects such as roads, bridges, utilities, maintains accurate proportional measurements, and used in civil engineering, surveying, and mechanical drawings. And of course, landscape architects, irrigation designers, they will use it probably just for site plans, their base plan, and their master plan, not for construction details. Excuse me. Some common engineer scales. 10 scale is 1 inch equals 10 feet. 20 scale is 1 inch equals 20. 30 scale is 1 inch equals 30 feet. 40 scale is 1 inch equals 40. 50, 1 inch equals 50. And 60 is 1 inch equals 60 feet. The top two is what we're going to use primarily in the landscape and irrigation business. I did have a good friend, Jerry Weicker, used 30 scale a lot just because of the size projects that he was actually using. And I have seen 50 scale, but very rarely have I seen 40 and 60 scale. Triangular ruler with 6 edges. So basically, you got 1, you got your 2, you got your 3, 4, you got your 6 edges. Each edge marked with a different decimal scale. Numbers represent feet in decimal format. So how to read the scale? Identify the correct scale for the drawing, place the 0 at the starting point, and then read the measurement in decimal feet along the scale. Fractions and subdivision. Engineer scales use decimal divisions, tenths, easier to calculate compared to inches and fractions, and allows for precise measurements of distances. Comparing the scales. 10 scale, 1 inch covers small distances with detail. 60 scale, 1 inch covers larger distances, and choice depends on the size of the project and drawing feet. So basically, choosing that correct scale. Match the project size to the paper size. Ensure details are legible and fit on the drawing sheet, and always check the title block for specified scale. Now, again, I always tell my students, we're going to start off with trash paper, and we're going to take like the widest part of the property line. So I'm always going to kind of draw that property line first. And if it's like a 75-foot wide lot by 150 feet deep, I'm going to take it and I'm going to draw 75, 150, and I'm going to see if it fits on an 18 by 24. If it doesn't, because I also have to take into effect my title block and my edges that I'm going to draw, I may have to bump it up to a 24 by 36. So I draw that property lines really quick to see if it's going to fit on my paper. Now, when I place it on my paper, I also got to leave room for my plant list, my irrigation parts, some details or whatever. It just depends on what it is that I'm drawing. If I'm drawing just an irrigation design, it may only be one sheet for the project. Site plan, got my landscape on it, drawing where my heads are and the zones. I'm doing that record drawing, as it's called, not we call it record drawing because we're irrigation contractors. We don't call it as-built because we're not licensed engineers. But make sure your project matches your paper size. Again, always check the title block for the specified scale if we're reading one, but also if we're going to draw one, we need to ensure that it fits on the drawing set. Now, at the end of this lecture, you're going to see me drawing these lines using the architect and engineer scale. Drawing it helps you to be able to read it in future. And I love seeing these landscape architect students in studio here. So mistakes to avoid. Again, using the wrong scale edge, mixing architects and engineer scales, and forgetting to confirm the drawing's stated scale. Real life applications. Roadway plans, utility layouts, site grading, and topographic maps is what we will use this. You can see here is a grading plan. We're doing the swells around it. Very, very fun to do. You got your finished floor elevation, your garage where it's at, and then we've got all of our spot elevations, and we're getting that water away from the home. Pro tips: label the scale on all drawings, double check measurements with a calculator, and use sharp pencil and neat line work for clarity. Again, keep that pencil sharp. Use the mechanical pencil, and you'll see the tools that I'm using actually in the video. And so, summary and review: architect scale, tool for converting drawings to real size. Select the correct scale for drawing. Practice reading and converting your measurements. With the engineer scale, it's decimal-based measuring tool. Select the correct scale for drawing. Practice converting drawing measurements to real-world side. And any questions or answers, you could email them to me, ejones@turfteacher.com. And guys, that does wrap up the lecture portion of this course. And so now you will look at the next video of me actually using those architect and engineer scales, drawing some lines. And then you will also have some sheets, the sheets that I'm actually using, the architect and engineer labs. They are loaded up to the course, and you can print those off and do those yourself. Thanks. And this is the Turf Teacher signing out. I will see you in the next lecture.